Good afternoon, everybody. I hope everybody can hear me. Welcome to our PLC introduction course on CoDeSys. My name is Hannes Otto. I'm manager for training and consulting for Festo South Africa. Our presenter today will be Dawie Pieterse. He's a trainer for us for our PLCs. He's also a trainer for Siemens. So he's got a lot of experience, and I truly hope that you will get a lot of value out of this. What Dawie will be doing today is he will just show you more or less some introductions on PLC, just cover the very basic principles. In the webinar, the 4-day webinar that's also available later on in this month, you will be downloading your own CoDeSys program, which is free of charge, and you will be doing some exercises yourself on the CoDeSys program or on CoDeSys itself. So we really want you guys to have a look and see that, like I say, this is basically an overview of CoDeSys, and on the webinar, on the 4-day webinar, you will go in depth into CoDeSys, do your own exercises, be able to ask a lot of questions, a lot more interactive. I would like to share my screen with you just to show you the courses that will be coming up. All right, so today we've got our free our introduction to PLC CoDeSys course. Let me just get I hope you can see the cursor. So the introduction to PLC. Tomorrow we've got a fluid sim course. Now, if you guys consider to attending any one of the basic pneumatics, basic hydraulics, or electropneumatic courses, I would suggest that you attend the fluid sim course because on those courses you will be making use of fluid sim to do your own exercises, interactive exercises, do designs and simulations. So if you are doing any one of the other courses, please consider to attend tomorrow's fluid sim training. I will also send this as a handout, so you will have the links on there. Then we also have a look at the 4-day webinars. From next week on, we've got the basic pneumatic webinar. Like I said, it's a 4-day webinar, 2 hours per day from 9 to 10 daily. And all 4 of those days should be attended. The same goes for all the other webinars because we won't be able to put everything in 2 hours. So we divide it over 4 days. Basic hydraulics would be next, 23 to 26 July. Electropneumatics, 29 July to the 2nd of July, 29 June to 2nd of July. Introduction to PLC CoDeSys, similar to what we've got here, just the in-depth course will then be 6th to 9th of July. And something that I think would be beneficial to a lot of customers and a lot of people is how to integrate Festo equipment with Siemens PLCs. A lot of you sit with Siemens PLCs in your plant and you are not completely satisfied with the knowledge of how to connect Festo equipment to your Siemens PLC. So that is a great course. It covers the field bus, it covers the GSD files, it covers a lot of aspects to successfully integrate your Festo equipment to PLCs. I would also like to encourage you to ask questions in the question tab. Charles Bont is on the other side as well. He's our co-presenter. So he will be having a look at the questions tab. Please raise your hand. There's a tab where you can, or a little button where you can raise your hand if you want to ask something. And then if you want to ask, then they will also unmute you so that you can ask a question if you don't want to type it. I hope you guys enjoy the course. Thank you so much. This course will also be recorded and it will be on our website under the tab Post Courses. So please go and have a look there if you want to have a look at the course again. But thank you very much, Dawie. I'm going to give it over to you. And please, guys, enjoy, ask questions, be interactive, make this 1.5 hour count so that you not waste your time. Thanks very much, guys.
Right, stop sharing that slide, please. Hannes, stop sharing that side. Okay. Right, good afternoon, everybody. Like Hannes said, my name is Dawie Pieterse. I'm actually a trainer at Festo. And I'm going to take you through this introduction to PLC, the free webinar. If there's anybody that actually are out of South Africa and your country and it's morning, good morning to you, afternoon to everybody that actually is the same time as us. Right, guys, welcome to this course. I'm going to start off today, actually explain what we will cover if you're attending our 4-day paid webinar. Module number 1. We created an exercise to know how the 3.5 CoDeSys works, now to set up the interface between the program and device and PLC. And that means that actually is a 4-day course. We got 5 modules, and the last module is actually then for the people that actually want to do the assignment. All right, that's all the course overview of the full paid seminar that you can attend from Festo. All right, guys, I normally ask these questions when it comes to training, to face-to-face training. I assume there's a lot of electrical guys, instrumentation guys, and also some of you guys that are actually mechanical. Welcome to this course, and please, you can ask questions, and I will try my best, and I will definitely answer your questions. All right, what we're going to do today is, guys, this is the table of content. What is CoDeSys? How to create a project, and then that means within what we're going to deal with, the objective for today is to give you an overview of what CoDeSys is, and also have an overview of the working principle of a PLC. It's very important for anybody that wants to attend a PLC training to understand the working principle of the PLC. And there's 3 parts, and I'm going to explain that 3 parts to you. Right, we will talk about all the stuff. What is the CoDeSys, creating a project, declaring a global variable. I'm going to touch on the Windows, and I will definitely do a basic program in the ladder, and then I also will do a basic program in ST for you for today to show you and to showcase to what CoDeSys is all about. Right, what is CoDeSys? The first question that you can ask yourself, what is CoDeSys? And CoDeSys is developed by a 3S, they call them Smart Solutions company within Germany. They actually are the creators of the CoDeSys software. The word CoDeSys stands for Control Developed System. That means where it's a software package that is actually what we refer to as standard. It's a standard. It's according to the IEC 6113-3 standard. It's a standard within the industry. All right. Now, we said that CoDeSys is what we refer to device-independent PLC system. That means it's a software company that develops the software, and it's not actually according to a manufacturer's specifics, but it's actually, what I said to you now, is a standard. It's a device-independent PLC program system that actually are developed by Smart Software Solutions in Germany. Right, there it is. Like I said to you, it matches the IEC 61131-3 standard. The software is absolutely available for free for download. Right, and more PLC vendors, that means companies that manufacture PLCs, are actually also integrated into the software of CoDeSys, and then you can utilize that software to program and to configure your PLC. All right, Festo is one of the companies that actually have their own CoDeSys software that's the same as what the 3S Smart company actually from Germany developed. It also is a standard within the PLC programming. All the PLC program languages within CoDeSys is actually according to the IEC standard, and I'm going to explain that to you a little bit later on again. Currently within Festo, we are using version number 3.5, the new software. It's already on version number 12, around about there. I think CoDeSys, when you go to CoDeSys website, you will find that CoDeSys is already using version around about 16, if I remember right. But we are currently using version number 12. Okay, this is all the IEC program languages. There's 5 program languages according to the IEC standard. And I assume everybody that actually have a little bit of background PLCs will know that ladder diagram is like a universal program language when it comes to PLCs. Function block diagram is also a graphical language, the same as ladder. Then there's instruction list. There's also what we refer to structured text. Now, structured text and ladder is the two software program languages that are being used by CoDeSys, and that is actually mostly, how can I call it, mostly used by a lot of companies, integrators, and companies that actually utilize PLCs. All right, it means now that ladder diagram, guys, ladder diagram, function block diagram, instruction list, instructed text, and then the last one is what we refer to sequence function charts. That is for sequences, right? It's like the old basic flow diagram language. All right, that's now the 5 languages that is part of the IEC language standards. All right, here on the bottom, I'm also talking about additional CoDeSys languages. There's additional 2 of them, continuous function charts. And then also when it comes to continuous function charts, there is what we refer to page orientated. All right, now this is the languages that is available within CoDeSys 3.5, and I'm currently using Service Pack 12. Right, your first one is a form of ladder one. Then you got number 2 is your function block diagram. Number 3 is the instruction list. Now, basically, what instruction list is the same as what other companies call STL, statement list, very close to statement list. Then we got number 5 is your sequence function charts. It's the same as other companies that using graph set, very close to graph set or graphed. And then we got number 6, like I said to you, is the continuous function chart. Number 4 is the structured text. Now, I normally refer to structured text as the same as C# or C or C++. Okay, for the people that actually have a higher qualification when it comes to programming languages. All right, for today, what I want to do today is, guys, listen to this. I am going to show you how to understand the fundamentals of literally any PLC system. That means I'm going to actually show you the working principle that actually all the PLC actually are based on. This is really just one part of the larger path. I'm going to show you and walk you through today all the important steps and the nuances that you need to know right now to understand any PLC system. That means after today, you will be able to explain to somebody how a PLC works and what is the working fundamentals of a PLC. So there are 3 things that you need to understand to get the fundamentals of any PLC system about. What is it all about? That means there's 3 things that you need to understand that is actually make a combination of that 3 makes up your PLC automated system. Right, so there are 3 things, very important, your inputs, then we got our logic, and then we got our outputs. These 3 things, I'm going to discuss these 3 things to you, and it will give you a good understanding and a good actually background about the working principle or the overview of what PLC is all about. Right, now I'm comparing your logic part or the PLC that is your controller. I'll compare that to the human brain. A PLC controller is like your brain, right? It needs an input before it can make a decision to do anything, right? That means your PLC will make the decisions for you on your behalf according to your philosophy and according to your system, right? Now, I normally explain this when it comes to actually sight, sound, smell, and taste, and also touch. That is the 5 basic human actually that actually your experience. You can actually see, you can hear, you can smell, you can taste, and also touch. That means that is all the inputs into our brain. Inputs into your brain are 5 senses. That means that is the 5 senses of a human being. to understand when I talk about an input. Your input, you look at something and then you make a decision. That is the input part. All right. That means when you arrive at the robot, you see the red light, and that is actually an input into your brain. That means the moment when you approach the robot, you make a decision. What do you need to make? You need to make a decision. Now I need to actually put my foot onto the pedal and so that I can stop. And that is the output part. That means within the PLC, you got inputs. Your brain is your controller, the CPU. And then the output part is actually when you make a decision according to what you have think about and how you analyze it within your brain. And that is your reaction. And that reaction is the output. All right. And now you can compare this to a PLC. All right. I want you guys today to get a clear, absolutely a clear, get clear understanding. So there are three things: inputs in a PLC, there's logics, and there's an outputs. And you need to know what is all the inputs and what is the logic all about, and also what is the output all about. If there's any questions, you guys are welcome to ask. I see there is some questions that guys ask. Please, guys, you're welcome. Right now, guys, listen to this. I'm comparing it in day-to-day environment where you are staying or where you are working. Inputs is like the sensor, guys. Inputs is like a sensor on a garage door. When it sends the sensor, then it stops the motor so that the garage door stops. That means you need a proximity, the proximity sensor. There is a photo of the proximity sensor that senses that your door is close or it is actually near. That means most inputs into a PLC are things like push buttons or proximity switches, like your garage door sensor that stops the door before the crash of your kid's bicycle or anything like that. That means the moment when the door comes close to your proximity and it is in position, it stops the motor. Now, exactly the same principle is within a PLC. These are called discrete inputs, meaning they are actually on or off, not in between. That means a proximity will give a signal, an input signal to the PLC, and that input signal can be on or it can be off. Right, this is input signals. There is a lot of components that actually will give you inputs. This is a summary of that there is actually limit switches, guys. There's limit switches. Right, there's limit switches, there's proximities, there's optical sensors, there's capacitor sensors, there's ultrasonic sensors, there's also auxiliary contacts or relay contacts or contactors. There's also push buttons. Now, this is all components that actually can be wired into my PLC, onto the input modules or the input part of my module. Right, now, for example, when it comes to the input, or you have wired now a push button onto your PLC, onto the input port, or what we refer the input of the input bit of a PLC, the moment when the operator pressed the button, it sent a signal. That means it's an input signal to my PLC. A limit switch is also an input device. Limit switches that sense the position of the garage door. That means the moment when the garage door are closed, the limit comes on, and that is an input signal into my PLC. Proximity sensors, guys. Proximity sensors. Proximity is close to the metal object. That means the moment when any metal object passes by or move in front of a proximity sensor that can sense that metal piece is in position. Is also contactless, if I can call it like that, but that can also be a signal into my PLC. Optical sensors have a much longer range of proximity sensors. That means they also utilize optical sensors to sense when there is a bottle or any other component that they want to maybe sense that it's in position or count. And that means the distance between the object and the optical sensor can actually be of a distance longer than what a proximity sensor is. That means in cases where there is big objects, for example, like use a box, there's a box on a conveyor, and as that box are put onto the conveyor belt and they want to sense it, that means the optical sensor will sense that there is a box or an object on the field. It can be small or it can be large. That means an optical sensor can sense actually also parts from a distance. Right, now here is an example. Here is an example of an object that I put with a robot onto a conveyor, and we want to sense that. That means we want to know where a box is on the conveyor. That means the moment when the conveyor are moved, but there is a robot arm that puts a package or a box or any other component or part onto my conveyor belt, then your optical sensor need to know, sense that, and that signal will be sent back to your PLC. A capacitor sensors, guys, there's also capacitor sensors. The capacitive sensors are like proximity sensors, but they sense non-conductible material. That means non-conductive material can also be sensed on the conveyor belt, and that is also a signal as an input into my PLC. Then also, guys, when it comes to ultrasonic sensing solid objects, that means if there is a solid bottle of any type of material that actually moving past the ultrasonic signal, that will also be sensed, and then that will be sent. The signal will be sent and transmitted to my PLC, and that means I also can actually then measure if know or sense when there is a solid object onto my conveyor belt. Right, now the same thing when it comes to, guys, when it comes to auxiliary contacts, right? Like auxiliary contacts, right here, there's auxiliary contacts of a 3-phase motor. I can also utilize that, and I can wire that onto my PLC so that my PLC can know when that contact closes, and that means that's also a part of my inputs into my PLC. All right, now here I've got a summary of also sensing devices, but this time it is what we refer analog signals. That means a PLC can take actually what we refer binary signals, that is discrete inputs, that is on or off, but we also can have input signals that is called analog signals. Now the analog signals have a range. For example, I normally compare it to 0 to 100. That means you can measure anything from the point you start to the end. That means from 0 to the end. All right. Millivolts, guys. Millivolts can be measured from 0 to 200 millivolts, or ohms can be measured, because according to the thermocouple, the thermocouple can have actually millivolts, or it can also measure resistance. That means we can also measure ohms. We can also measure position on a PLC. Humidity can also be measured. Analog proximities, for example, from 0 to 24, or from 0 to 10 volt, or from 0 to 20 milliamps, or 0 from 4 milliamps, 4 milliamps to 20 milliamps. That depends on the component. That means analog signals are also signals that can be wired into my PLC, and that is my input signals. So that means you have digital input signals and you have analog input signals. Guys, digital signals, in our case, for example, today we will say that there is a 1. We refer to it as a binary signal. If you refer to a binary signal, that means when the proximity sensor senses that there is a box, for example, on my conveyor, it will send a 24 volt. That 24 volt will be represented by a 1 in my PLC, or it can be also represented as an on in my PLC. It can also represented as a true in my PLC. If the proximity sensor senses that there's no box on my conveyor, that means that is a 0 volt signal. It will be represented by a 0. it represented as an off, or we can also represent it by actually the called false. All right, and I've already explained to you the analog part. All right, analog part from 0 to 100 or 0 to 10 volt or 0 to 20 milliamps. That's the analog signals that you can wire into your PLC. Right, now for example, I've mentioned now to you the binary sensors, guys. Binary sensors like a proximity sensor or a limit switch is what we refer a digital signal. All right, in our case, the power that we wired onto my limit switch will be a 24 volt. Right, now remember now, this actually limit switch for the garage door, for example, are represented as a switch. That means that's why we got it. Now it's normally open, a normally open switch. It means now currently the voltage that actually are sending is 0 volt. That's 0 volt onto it. That means it will be 0, it will be off, or it will be false. The moment when my limit actually comes on, the switch will internally close. All right, and that will send a binary value, or what we refer to a 24 volt value, in the form of a 1 inside the PLC. That means your PLC sense the 24 volt is present. Now the PLC need to interpret that as a 1, or the interpretation will be an on, or it will be interpreted as a true. Right, that's the binary signals that comes into your PLC. That means a PLC actually only understands zeros and ones. Right, it's not understanding 24 volt or a 0 volt. It actually understands it as 0 or a 1, or off or a false, or a 1 or a on or a true. That's how a PLC sends it. Now that value of the input device need to be stored somewhere within your PLC. And I will come to that later on again, and I'll explain to you what that means. Okay, for example, when it comes to analog values, now I compare that to your car's fuel gauge. Your fuel gauge can show you that it is actually half full, or it is full, or it's empty. That is an analog signal. To compare, that is an analog signal that are sent to your gauge onto your console of your car to tell you now it is your car is empty. The PLCs can also have analog inputs which are more like light dimmers also, for example. You might have in your house, instead of not on or off, that means an analog value is not on or is not off. It's anything in between. I think everybody understands your analog signals. Okay, guys, this is all the different types of, a summary of all the different type of sensors that can be sent or can be wired into your PLC. That means I need to wire my push button and my emergency stop, for example, or my level sensors for high level and low level proximities, or a thermocouple or a transmitter that actually sends what the temperature inside the boiler is, or maybe the water level, the level in that boiler. All this is actually can be wired into my PLC. That means analog signals and digital signals can be wired into my PLC. Right, now guys, now we come to the second part. First, we have discussed now all the input parts. Now we can discuss the logic parts, right, in the PLC. Now listen what I say. This is where the magic happens. This is where the magic happens. This is where you, as a programmer, as a technician, or as a system engineer, or as a philosopher of your machine, you need to put your thoughts, your mindset into your PLC. That means it's that same as what we said. You look at the robot, you make a decision in your brain, and that means you need to step onto your foot pedal, your brakes. You need to brake the car. Now, this is exactly, this is where all the things happens within the PLC. This is where you take your inputs and make some decisions so you can do some actions or action with your outputs. Just like your program, your brain. You stop at a red light. You can program the PLC to make decisions and produce actions. That means action. If this happens, then this happens. We will see that today. Right. Now, guys, PLC can be programmed in different languages, like I've mentioned to you already before. PLCs can be programmed in different languages like ladder logics or structured text. Now, this is the two most common or popular actually program languages that are being used within the industry. That means if you want to understand programming, please start off with ladder logics. The program language does not matter much. It is just a way to tell the PLC controller what to do with all the inputs it's getting. That means it's not so important, but yes, it depends on your preference. What do you like? What do you understand? What is actually understandable for you? Now, I know that electrical guys, everybody that are in the electrical trade, that is our technicians, instrumentation mechanicians, technicians, engineers, they refer to use ladder because ladder is the same as electrical circuit. It's the same as electrical circuit, very close to that. All right. The structured text, I will go through structured text also with you now. The most popular language, like I've mentioned to you, here's an example on my screen, is the ladder language, right, called ladder, and this is an example of it. And remember now, these two languages, both structured text and ladder logics, are international electromechanical commissioning standard languages. And that is the languages that we actually also do when we do the training within CoDeSys. Right, now important to start off to give you a little bit background and also a little bit of insight and understanding about ladder diagram. The ladder diagrams comes from the old relay logic panels where they've used relays for control circuits. All right, within ladder, we use normally open contacts. And we also use normally closed contacts. But a normally open contact need to be represented by a symbol within the ladder diagram language. Now, this is an example of a normally open contact within ladder. This is an example of a normally closed contact within ladder. And then my output part, the decision, after you have made a decision and there's a conditions, and that then you will make a decision, and that is going to my coil. Now, this is a symbol that represents my coil. Now, to explain to you how the ladder logic diagram works, we call that a rung. That means the first line is my rung, and then this is a part of the rung. That means I can go to a next rung in a new network, and I can add a new rung. But you must always remember that the output part on your rung is actually where we actually connect. That's why we actually refer this to actually relay logics. This line represents my 24-volt line. This represents my 0-volt line. And I'm going to show that to you and explain to you a little bit later on again. Right, is there any questions, Charles?
Nothing at the moment. I see no one is asking anything, but no hands are raised.
Okay, excellent. Right, guys, let me go on. If there's any questions, please ask, guys. Right, now I'm going to go into explain to you a little bit more about actually your program languages. Right, here's an example now. I will give it a moment. This is the structured text language. Like I said to you, it's actually similar to your basic Pascal and C. Right, now we use if the switch, then the lamp must be equal to 1. That means we use if and then statements and use else in statements. Now, right here on top, onto my slide, you can see that there is for, while, if, else, if, and case. That is all the instructions that we use within structured text. That is a more organized, you can see now we can organize your program, and you can actually also break it up into small portions, right? For the people that actually have a background of programming on higher levels, this is actually will definitely be easy for you. But for technicians and mechanicians and guys that's starting off with PLCs now, my actually advice to you is to start off with ladder, and then you can start programming with instructed text. But the moment when you catch what is going on, when you understand the principle of instructed text, the instructed text becomes like a second nature to you, and it is very easy. We can do a lot more with less lines, if I can call it like this, within instructed text. And I'm going to quickly do that today with you all. I'm going to show a program to you. Okay, now this is the output parts. That means, like I said to you, we have discussed now all the different inputs. We have discussed now, for example, what the logic is all about, but this is my outputs. And guys, I can add a lot more to this slide. For example, if the PLC receives an input saying that a motor is running, you could have a logic that turns on a light. For example, now you're right here on my panel, on this panel, it tells me that my motor is running. My electrical motor is running. That means your actually motor have actually an input that tell me that the motor is on, and it actually tell me inside my PLC, and the PLC know that, and then I'm sending a signal out to my control panel to tell me, operator, to tell the person that works with this system that the motor is running. Right. That means, also important to understand this, we can also have silencers for alarm silencers. We can have valves, for example, pneumatic valves, solenoid valves. There's a lot more to outputs than only this few. All right, that means now, that is the output part. Now to start off to understand now what the PLC consists of, all the parts that a PLC consists of. Guys, you please ask if there's any questions. All right, now guys, we talk about your processor. That is the CPU. That is what I refer to the brain of the PLC. Right, and this brain needs to be powered up. That means there must be a power supply. Right, the power supply. That means, to understand this, on this side we got our input modules, and we got on this side we got our output modules. That means we wire all the inputs into my PLC. All right, now there's different ways of doing it. There's different ways. There is what we call source, and we also actually got sync. All right, but I'm not going to go into much detail about it today, but I want to mention that to you also so that you know that. Now, for example, this now, we got a 24-volt line with two normally open push buttons wired as inputs into my PLC. Then I got two lamps wired from the output module. Right, now I want to mention so that you know this, a lot of PLC companies manufacture what we call a compact PLC. A compact PLC is, for example, I want to show it quickly to you. Hold on for a moment. I'm quickly going to show this to you. Right here on my table, guys, here on my table, I assume everybody can see it now. On my table, I've got now a Festo. They call it a CECC PLC. I'm going to quickly make it large so you can see it. I will make it very large. This is what we actually have. This is a compact PLC. At the bottom, we got 14 inputs. We can wire 14 inputs into it, and we can have 8 outputs onto this small PLC. Then it also have the ability, and nowadays within the industrial environment, when it comes to automation, a lot of people talk about I/O link. Now this PLC can actually have 5 channels right here on top, all right, where we can actually also have an I/O link connected to a module. For example, we can have actually remote I/O. Remote I/O can be connected onto the channels, and that means we can actually increase the number of inputs and outputs to it. 64, for example, 64 inputs. All right. That means this, you are not only limited to 14 and to actually only 8. And I must be honest with you, this is very affordable. You can ask people, this is very affordable for small automation systems, but it's a powerful PLC. I must be honest with you, it's a very powerful PLC. Okay, that means now on the processor, we got inputs and we got outputs. Now, it's important to understand that switch number 1 and switch number 2 needs what we refer to a physical address. It needs a physical address. Now, to help you a little bit to understand this now, this switch needs an address, and we call that an I for inputs, and then for the outputs, we're using a Q. Now, a lot of people can ask me, Davy, why do they use a Q, not a O? Guys, it is because a O and a 0 look very similar, right? And they have decided a long time ago that they actually will make the output a Q because that will be the identifier for inputs, a I for inputs, a Q for outputs. Then, for example, because it's one single switch here, we need a physical address. Now, let me assume this is a module that can take up, let me assume 8 inputs, and let me assume this is 8 outputs. That means it can only go to 8 inputs and 8 outputs. That means we start off with 8 bits. Guys, I've mentioned to you bits already, a bit, the bit input. That means that's becoming a bit input. Now the physical address, we will take all 8 of these bits together. All 8 of these bits together is called a byte. That means we're going to call that a byte. All right, that is equal to what I said is equal to 8 bits. All right, that will be equal to 8 bits. Very important to know this. That means if I have a combination of all 8, that means if there's 8 inputs, all right, for example, wired onto the input module, then we have 8 different addresses. But that 8 addresses share 1 byte. That means we start off, let me assume it's byte 0. Right, point. Then we have bit 0. That means, sorry guys, that means this is what we refer to the byte address, and this will be referred to my bit address. That means I will have my byte address, and I will also have my bit address. The same when it comes to the outputs. We will have output byte 0, point bit 0. That means now we can start off with 0, 1, 2, 3, and 4. We can go and we end up with 7. That means the last one we will go to 7. That means that is your 8 inputs or 8 outputs. All right. This is the basic components that makes up your PLC. If there's any, please ask if there's any questions. Right, now we can go on to the next slide. I'm going to go to the next slide. Right, very important to understand this part. Guys, they talk about cycle program execution. That means the moment when you put power to your PLC and you already have a program, already have a logic actually programmed into the PLC. This is the basic principle of working principle of all PLCs. All the PLCs work on the same principle. Right. We got our inputs. Yes,
sorry,
sir?
Davy. Now there's a question.
Yes,
why do we start our addresses at 0 and not 1?
Okay. Let me explain to you. The guys that manufacture PLCs have decided a long time ago, very long time ago, that the first byte address, guys, let me go back to the previous slide. The first byte address right, will be byte 0, byte 0. That means, because if this is my first module, let me assume you got, guys, I'm going to do it like this for you. This is my, let me see, you have more than one, let me see, three, let me see, there's 3 input modules and there's 3 output modules. Very good question. I like this question. There's, let me see, assume there's actually 3 output modules. Oh, sorry for my, I think you guys get my picture. Right. Now, the moment when you address your first module, okay, we start off, there's a rule that said that we always start off, they say that the first byte address, sorry, the first bit address, all right, when we actually wire this input into the PLC, when that is 0, if that is 0, let me assume this is number 7. Right, that means the first bit address is 0. Right, because 0 means something within the PLC. It's not like your bank account. When there's 0 in your bank account, that means 0. But within the PLC, 0 is a value. That means they also use that 0 for actually an address. And I will talk about this also in more detail when it comes to the bits and the binary, binary, decimal, and also octal and hexadecimal value system. When we talk about it in the PLCs, then I go into more detail. But it's good to ask this question: why 0 and why not 1? Because 0 is actually in a PLC's value. That's why they start off with 0, and then they say 1. That's the two values. These 2 values are actually values within the PLC because that's binary. And we start off with the first address as 0. Now, I always say to the guys, this is a rule. This is a rule. The first bit is also your byte address. Right. That means when you start off with bit 0, then we got bit number 1 and 2, 3, 4, 5 until 7. Okay, guys? Because now a byte 0, and then you get a byte 1, byte 2, byte 3, and we can go on. It depends on the performance capabilities of your PLC. How much inputs can be wired? What is your PII? And I'm going to explain that to you now. They talk about a PII, guys. Internally, inside my PLC. Very good question. Inside my PLC, right into the processor. Take my processor, and I can say this. There is another. Let me do it like this for you. Inside my PLC, there is what we refer to a PII table, and on the processor again a PIQ table. Right, it's called process image input table or process image output table. Right, let me go to the next slide, and then I'll also explain a little bit more about why 0 and why not 1. Okay, I'm going to go to the next slide. Right, inside the PLC, guys, within my PLC, if I wire my input, my digital inputs and my digital outputs into my PLC, right, internally inside the PLC, listen what they said here. They say, right here, I'm going to show it to you right here, right there. We see that reading the input status from input modules and saving the status in the process image input table. Right here also, that is what we refer, writing the process image output table. Now guys, listen to this. When I wire my PLC, inside the PLC there is what we refer to as status, a table that actually holds, and some people will call it hold, some people know it memory. That's your memory inside the PLC. Inside the memory of the PLC, there is what we call a table. That table will be actually like a placeholder for the condition or the status of inputs and also the statuses of the outputs. Right, that means when you wire an input like a push button that we've done on the previous slide, when that is wired into my PLC and I push the button, that condition becomes a 1 when it is on, or when it is true. It becomes a 1. Where did they store that bit, that value? Where did that value be stored? That value being stored inside my PLC, inside the PLC, inside the memory. It's called my process image input table. The memory for the output is called the process image output table. Right, that means when I start the program, I call my program. I'm calling my program. That means the program or my logic that I've written into my PLC. I'm calling it. That means I'm calling my program. This is what they say. Call and execute. Execution of after the power is on. That means the moment when I start my PLC, it's going to run mode. That means when I switch my PLC on, it will go to run mode, and that values will be stored inside my PII. Then I execute my task or the logic internally. We will go into this detail a little bit more when you do the official, actually 4-day course. I will talk about the main program, and I also will talk about the task configurator. I'm going to show it to you later on again. We got what we call a POU, guys, a POU. And then the POU is called program. It means your conditions of your inputs are stored inside your PII. When you want to execute your logic look at what is the condition inside your PII. Then it make a decision according to the logic and write the of your program into your PIQ table. Into your PIQ table. And now we cycle. Now this is how it cycles through my program. And this is why we call it CPU cycle through your program. This is continuously happening inside your PLC. If you understand the basics of this, all the PLC companies, all the PLC works on the same, exactly the same principle. Right, it works on the same principle. Now, let me quickly go to the next slide. I hope this is fine for you guys, and I hope it's not too advanced. Right, now guys, here's an example. Here's an example of my PII table. I said to you, you always start off with byte 0. Why? Because this bit here is bit 0. And we allocate the address of the byte 0 because of the bit 0. And then we have byte 1, byte 2. Guys, in that, this can be your program. Right, for example, I've got a normally open contact here, and I got a that means a normally open contact with a coil that is like a relay. That means the moment when your PII sense that there is an input on, for example, in my byte 2, bit 0, that means input 2.0. That means input byte 2, bit 0 is on. If it's on, if it's a 1, it will be closed here. It need to also put my K1 on. Where do it K on? It's actually according to the output 4.3. In my PIQ table, it puts that bit on because this is bit 0, 1, 2, 3, and 4. 4. Then we go to bit number 3. 3. We always start from the right hand side from the right to left. We talk about on your right hand side is what we refer to. Guys, important to know this principle. For guys, this is what we refer to. This side is my LSB, all right? And in this side is my MSB. We call that MSB, all right? We call that MSB. That is my least significant bit. My least significant bit is right here. My most significant within a byte is right there, all right? I will go into more detail, but this is basically the principle how a PLC works, right? Now, guys, I want to start off showing you now within a real PLC because our time is actually running out now. I want to go to the PLC software, what we call CoDeSys, and explain to you this. But the most important thing about a PLC is the following. Listen to this. I'm going to exercise with you. We're going to work through this exercise. But listen to me now, guys. Very important to understand this part now. And everybody struggle first time when you work with a PLC. The question is, how do I connect? How do I connect with this PLC? What is the interface? We call it the interface. How do I interface with this PLC? Right, because in the age of we now are, the modern days, guys, we make use of industrial Ethernet, or we talk about, in other companies, they call that Profinet, they talk about Profibus, they talk about Modbus, they talk about CAN bus. There's a lot of different protocols when it comes to the connection or your interface or the setup within your software. Now, guys, listen to me. I'm going to show this to you. It will help you to understand, actually. PLC, of course. All right, I'm going to show you my PLC. On this PLC, for example, we got now, right here, I'm going to show it to you. Right here, we got there, we got there. Right there, we got an interface. That is what we call industrial Ethernet interface. That use a CAT cable, a RJ45 plug, and then this is what we refer to CAN open. This is my CAN open communication. Interface this now with actually what we refer to an interface is your industrial Ethernet. That means the physical address for this CPU will be an IP address. Sorry guys, but this is IP. IP stands for Internet Protocol address. Right, and then later on, when you guys come for our courses, we also will talk about CAN bus. We will talk about CAN bus. Right, I hope it makes sense to everybody. If there's any questions, please ask again.
No questions at this stage, Tommy. Everybody's so happy.
Thank you. Okay, great. I hope it's not too advanced for you guys. Right, guys, here's an exercise. What I want to do within a physical PLC. I want to go now over to the software called CoDeSys. I want to show you what the navigation and the setup is within CoDeSys. When you're attending our courses, we will use this software to creating a PLC program. You know now what input is, you know what output is, you know what logic is, you also know now how a PLC works. And I've referred it to the scan cycle, that is the PLC scan. Yes, sir? Any questions?
Sorry, Davy, somebody raised their hand.
Yes.
It is Anderson OB. Oh, Anderson OB raised. I'm not sure what the question would be. So Anderson OB, if you could just speak to us and ask your question.
Can you maybe unmute him?
Yeah, he's unmuted. Anderson OB.
Hello, yeah, I can hear you.
Hello.
Okay, can you please ask us the question that you?
Hello. Yeah, yes. Can we give a light on the CAN bus system? The CAN bus technology.
Yourself,
can we give a brief? Hello.
Yes, sir.
Yes,
the CAN bus technology. Can we talk something on CAN bus technology before we proceed? CAN bus in your presentation.
Okay, if I understand your question correctly, you ask what is CAN bus?
Davy, I think he wants an overview of CAN bus. Yes.
Yes, sir. Okay, yes, I do.
Let I help you at the end of the session. Please stay on, and then I will actually explain to you what CAN bus is. Will you be able to do that? I will do that with you. At the end of the session, I will explain to you what CAN bus is and what CAN bus stands for. Okay. It's very good to understand it. Very important to understand this when you actually work with PLCs. That is a protocol, very important protocol. Okay. Right, now what I'm going to do is, right, I'm going to do this exercise. We got an exercise here called warning lamp. I want to create a small program within my PLC. And I said to you, I'm going to use CoDeSys. and the CoDeSys will be actually the software. Like I said to you, we use currently within the Festo environment. We use CoDeSys currently 3.5 version 12. All right. I'm going to bring up my CoDeSys into my screen so you guys can see it. I assume everybody can see my screen now. Show.
I can see it. Yes, it's there.
All right, guys. This is actually now the CoDeSys software. This is how it looks like. I'm going to start off with a new program. That means I'm going to go to File. When you open it, guys, when you open your software, you can go to File. You say New Project. All right, and this is what we do. Then you select the project what you want to do. That means I need to be in a project. Very important to understand this part. I'm going to show that now too in my slides again. I want to start off with an empty project. Now, one important thing is I'm going to call this warning. I call this warning lamp exercise number 1. And I'm going to say, okay, the moment when I say this, do you want to save it? I'm going to say no. Okay, I'm starting off with inside CoDeSys now. This is internally inside CoDeSys. Okay, inside CoDeSys, I've created now a name for my project. I'm going to right click onto it. Now, guys, what I like about CoDeSys, very important, what I like about CoDeSys is, guys, it got what we refer to as simulation package built into it. It means the moment when you download CoDeSys from the Festo website, you can go to Festo's website, you can go to the support and downloads, and then you can go down to download software, and you can, in that side, you can actually go and download the software from Festo's website for free. There's no license involved. There's no license fees that you need to pay. That means everything is for free. Right. Now, guys, what I'm going to do is after I've downloaded it, I've installed it. Now I'm going to right click onto it. Now I want to add the device. That means my first step when I start a project into my CoDeSys is to add a device window. This is my device window right here. This is my device window. Then on the device window, I created my project name. And on my project name, I'm going to right click onto it. It will give me a drop down menu, and I click add the device. Right. Now the next window, all right, let me quickly bring up my next window for you. All right, this is the window that will come up for me. All right. Now, because I'm going to utilize now the internal software. All right, the internal software from 3S Smart Software Solutions. This is all the PLCs, but when you click on display, it brings up all the different versions of the program. Right, and now I'm going to use the internal PLC. That is the soft PLC, guys. You need to understand this. If you never have worked with this software before, it's a soft PLC built into the software. That means it's like a real PLC, but it is now internally inside the software. When you download it, when you install it on your machine, it will be available for you. All right, I'm going to say then, on this, I'm going to say add. The moment when I add it, you will see on my left-hand side now. On my left-hand side, it actually adds my controller now. All right, I'm going to close this window. You will see now right here on the left-hand side, I've got now my controller installed. All right. Now, before I can actually then start programming, I want to establish communication. And this is now the part that I've said to you that is actually always tricky for a lot of people. Everybody always struggle how to connect to your PLC or to a device. Okay, now I'm going to right click onto this now. And then we can go to the simulation, but my simulation is already on. I want to show that to you. My simulation is in the form of a small PLC. And unfortunately, I cannot show it to you now because it's on my opposite screen. But I know it's on, and I'm going to show you what happens when the moment when I click onto, okay, my PLC is already on. I'm going to right click here and say, double click onto it. It brings up what we refer to my communication settings. And you need to set up, the first time when you set up CoDeSys, you need to create a gateway. Now, the gateway is actually like a door that goes open. That means I'm connecting to that gateway. It means it must be on the same range, and we can go into more detail. When you're actually attending this course, I will go into more detail. Now, because I'm using the internal PLC, the soft PLC, not an actual PLC, not a hardware PLC, I need to have a name for that PLC. Now, my name for it is my desktop. I'm clicking right here, and I go over to the other side and say set active path. Guys, the moment when this change into a bold color, then I know it will be connected, it will be connected to my PLC. That means it's connected now currently to my CPU, to my device. Okay. I'm going to quickly go back into my slides. I want to quickly show you something in my slides. Right. It means now when you create a project, you start working with the CoDeSys, click on the desktop icon. That means this icon will be there. For example, there is 3.5 Service Pack 7. This is how it will start up. Then after the software is started, you're creating a new project. And this is what I've showed you. All right. Then you start the new project wizard, or you can say file, new project. You click on file, you see new project, and then you create yourself a project. And that's what we have I've done. All right. You select the empty project, give the name to the project, right? And then you say, and then you press onto the OK button. The moment when I say OK, if you want to, you can modify the folder of the project, where you want to save it, where you want to stay it, where you want to, or you want, what do you want to call it, for example? I can call it like that. Okay. This is now the PLC that we use. We use the CoDeSys controller Win version 3. That's the controller that I've chosen. That is the software CoDeSys PLC. Right. Now I need to add into this a PLC program. Right. I'm going to go now back to my CoDeSys software. Right. Inside the CoDeSys software, right, I'm going to click now on application. Guys, I will go through the structure. I will go through all the windows. Normally, when it comes to a real PLC training, that means a 4-day paid customer paid training. We will go through all the different windows. That means when you're actually attending one of our webinars, paid webinars, I'm going through all the different windows with the guys. That means the navigation, because navigation is very important. The first time when you start using CoDeSys, it can be tricky where to go and where to look for and what to do and how did it works and how did it falls in. But now, because this is a free webinar and I want to actually show you how a PLC program works, right click onto the application and I want to add now an object in the form of a POU. There is a POU. What a POU stands for? Program Organization Unit. Right here you say creating a new POU, Program Organization Unit. This is now like a program actually folder, and I'm going to do my logic. I'm going to write my logic of my warning lamp right into this. I'm going to call this now warning underscore lamp underscore LDD. Right. Then right here at the bottom, I'm going to choose my my language, my program language. Right there, there's all my program languages. I'm going to click on ladder diagram language, and I'm going to add this into the PLC. Right. Now look at it happen there. Sorry, within my software now. Now, the moment when I've actually added that POU, this is what we refer to the POU. This is where you actually can start writing your program, what we call the program editor. This is a program editor now. I can edit my program right here. I also need a task configurator. Right, I'm quickly going to show you something according to my slides. I'm quickly going to show you something right here on top again. I'm quickly going to move back to that position, sorry, that position. I've said to you in this cycle, all right, I say to you within this cycle, the PLC, that's a CPU, the main program in the task configurator. That means I need a task configurator, then I need a PLU. All right. Now, what is the task configurator? Let's explain this to you. The task configurator is the CPU. That is the task that will execute your PLU, the program that you're going to do within your PLU, right? It will be executed by the task configurator. I know it's actually difficult to visualize what happens now within your PLC, but let us show it to you on the real PLC, and it will make more sense to you. It will become more sense to you. All right, let me open the CoDeSys again. Okay, within CoDeSys, I'm going to right click now onto application. I'm going to add myself another object, and that will be my task configurator. Right at the bottom, the task configurator. Here, right here at the bottom, there's the task configurator. This is a task configurator. I'm going to say add it into my PLC program. Right now, this is my main program, the task. Right here is the main program. Now, I normally explain this to you. You don't need to program, or you don't need to have a function or a statement or an instruction for this from the CPU side to execute the task. But the task, internally inside the task, I need my POU, my program, my POU, my program organization unit. Right, but before we add that into, yes, sir?
Dawie, we have a question here from Olabisi. He's asking, please, I want to know if the Siemens PLC can accept the CoDeSys software, because I'm only aware of semantic version as their software.
Okay.
So he wants to know if
right, did I help you? Remember now, Siemens, sorry, Charles, Siemens utilize Semantic Manager. All right, Semantic Manager, it's a totally different software package. It's not, Siemens cannot use CoDeSys. Siemens cannot use CoDeSys. It's two different manufacturers. Both are German orientated. That means German manufacturers, all right, of developers. It's two companies, two separate companies. 3S Smart, right, and that is CoDeSys, and then you got Siemens. Now Siemens got two software packages called TA Portal, Total Integrated Automation Portal software, and then they have also Semantic Manager, Step 7 Semantic Manager. Siemens can unfortunately not incorporate it into the CoDeSys software. All right, unfortunately, but I want to explain this to you. What we can do is we can actually connect a Festo CECC CPU as a slave component within the Siemens world. All right. You can actually also connect on Profinet. You can also make a Siemens PLC as the slave. All right, in CoDeSys. All right, I hope that answers your question. You are correct. We cannot use a Siemens PLC within CoDeSys itself, but you can actually establish communication like a slave and a master and a slave situation when it comes to the PLCs. All right. Guys, to come back to this, I hope that answers your question. I know it must supposed to answer your question because I know for sure you cannot actually utilize any Siemens components or hardware within the CoDeSys world. All right, guys, integrated, if I can call it like that. All right, now listen to this. I'm now going to go into my warning lamp. I'm going to open the warning lamp, and according to my slides, according to my actually exercise, they say here a warning lamp Okay, you can look at this. A warning lamp is activated by means of a switch at a remote location. The warning lamp stays on as long as the switch is activated. When you deactivate the switch, the lamp switches off. All right, that means it's a push button or a switch, and when you push the switch, the lamp comes on. All right, now the whole idea of the whole objective is you must be able to create a project within CoDeSys software, be able to write a PLC program with ladder, also with instructed text, and then be able to set up a PLC device with a PC. All right, that's the main objectives. Now, this is the same objectives that you will have with other exercises when you do a paid seminar or a webinar. All right. Within CoDeSys, what I'm going to do now, I'll need to hurry up now. I'm going to now create myself, according to my POU, I've said I want to program into ladder. Now, guys, I've talked about normally opens. I've talked about the normally closes. Here is my ladder elements. Here's all my ladder elements. I'm going to click onto this. It's a normally open contact. And I'm going to have a coil. I click onto it. I click here and I drag and drop. Click, drag and drop. Right. Now, guys, that is a normally open contact. Right. Because we are not working with a physical PLC. We're not working with a PLC now. That means I don't have input addresses. Because this is a soft PLC. This is a soft PLC. I'm going to create what we call an input bit, and I'm going to call it with a symbolic name. Check here. What I'm going to do is I'm going to type in there start. All right, now let me make it push button. I think it's better. Push button. Look what happened. I'm going to enter it once. The moment when I enter it, it will be a bool. That means it's a bit. That is my address. That's my symbolic address, because we can give an input a symbolic address, or we can give it a physical address. An input can be a physical address, like I said to you before, an input 0.0, or I can also allocate a symbolic name to it. Why do I need a symbolic name? A symbolic name is a meaningful name, something that means something to me. It gives meaningful to an input address. All right. For example, I can say now here, percentage, all right, I, and X is a placeholder for a bit, and I say 0.0, and I enter it. Right, look back in there. That means that is now my address. That is my physical address, and this is my symbolic address. I hope you guys can see it here on top. All right, then I'm going to add myself now here also another name. I'm going to call that name lamp, and I enter it. Right, the name is lamp. Okay, and I'm going to actually give it also a physical address, an output address. I'm going to say, right, percentage sign. This is how CoDeSys is doing it. A QX0.0, and I say okay. Okay, that's now how you a push button is connected to that physical address there, and the lamp is connected to my output address. All right, now this is my program. That means now the moment when I press or I close this normally open, my lamp comes on. Right, I need to download this program. The moment when you are finished editing your program, you're satisfied, you need to download it from your program device, that is my PC, into the soft PLC. I'm going to go to Bolt. This is how you do it. Check Bolt. All right. Right here at the bottom, it tells me there's 0 errors. There's 0 errors, 0 warnings. I'm going to go to online, go to multiple download. Always perform a download, guys. This is how you do it within CoDeSys. To get now your software that you have done inside your PLC, okay? Okay, now I know it's downloaded yet. The screen tells me now it's downloaded. I'm going to test my PLC now. I'm going to test my PLC program. Now, I don't have a physical button or a physical push button. I need now to make use of the simulator. Now, the simulator need to actually check, or what we refer to, a normally open is the following. Listen, guys. This here, a normally open on your ladder program is what we refer to a check. We check. What do we check for? Very important to understand it. We want to check now for a 1. That is a normally open is checking for a 1. A normally closed is checking for a 0. Right. We will go into more detail. We are actually, guys, attending our course. Right. That means the moment when this condition closes. Right. I'm going to quickly show it to you. Go back here. I'm going to go into what we refer to now online. Right here is lock into the PLC. Click on that icon. It will go take me into the PLC. Check what happens when I click onto this. Okay, nothing happens here. With a reason. There's a very important reason. Because I did not add this program into my task configurator. All right. I need to go back into my task configurator. Go to the task. Open the task. Add the call. What do I need to add? I need to add my POU. Right? Add call. Go to application, check what happens. There's a small delay into this, but it will come up now for you. Then I'm going to go to add application. Right here is the POU, my POU program. Click onto it, say OK. The moment when I say OK, right here at the bottom, it will be added into my PL. Right here is now inside my task configurator. My POU program is now part of my task configurator, and the task configurator will be instructed by the CPU to execute my program. I'm going to go down to online, download again, make sure everything is downloaded into the PLC. Okay, and now I'm going to switch on, lock into the PLC. Check what happens now. Go back into the PLC here. Right, now you can see that there is my push button and my lamp. Right here on top now, there's what we call a prepared value. Click onto it once, right? And then I want to modify that. Go to the online and then, to debug, and then say write the value. The moment when I say on now, I can see my lamp comes on. It means that simulates now. If I press the push button, the lamp comes on. All right. I'm going to quickly show you something else. I can also add into, and this is what we also do on our paid seminars. We add what we call a visualization. A lot of people know that or are familiar with HMIs, human machine interfaces, attached panels. All right, I'm going to right click here, go to the end and say, right, I want to add my visualization. Okay, there's my visualization. I'm going to give it a name, add it. All right, guys, it takes a time now. Give it a moment. It will be there shortly. Right, what the HMI means, guys, remember now, a lot of people know it as your SCADA packages, or it knows it as a touch panel or control panel. When you come to a control panel, right? I've opened my visualization. I could create a push button, click this, drag it over, guys. I'm going to a little bit add that into this. This is what you will do, guys. Oh, I see. Right, let me quickly do it again for you. Right, I'm going to go to on my right-hand side. On my right-hand side, right here, I'm going to create my own push button. Click onto it, bring it over into my screen. I hope you guys can see it now. Okay, I'm going to create a push button. I'm going to Right, guys, I want to change the color of the push button. That means I'm going to go to my visualization properties. And I'm going to go to color. Yep. Okay. Guys, give me a moment. Let me see. There's red, and the long color must be green. Let me make it green. Make it. Make it red. Okay. And then I'm going to quickly create, guys, quickly, I'm going to add myself also what we refer to in my toolbox. This is what we will do. I'm going to create a lamp. Quickly get a lamp there for you. Okay, this is a lamp. Okay, and on the properties, I'm going to quickly show there. Guys, I cannot show you everything, but I'm going to quickly show this to you. And according to this, the moment when you come into your properties, when you click onto your push button, you can actually go to toggle view, and I'm going to add my, actually what we refer to my inner warning lamp in my push button. All right, that means I will add my push button tag. They call it a tag, or this tag will be connected onto my push button. I'm going to click on this one, and that will be my click here. And that will be my lamp. I also want to quickly change this color. When I click onto the push button, I need to change the color. I want to demonstrate this to you so you guys can see this. Okay. Right, I'm going to give it a name. Text there, call that push button. All right. Enter it. And I'm going to quickly go to build it and download it. Okay, guys, what I'm going to do now is I want you to show you both this programs. Okay. I'm going to show that to you, Windows. And I'm going to switch it on. I'm going to switch it on or log into my PLC. The moment when I click onto my push button on my visualization, I put that on and my lamp comes on. That means this is what you also will experience when we do the training. We will also do visualization with you. That's actually now, I can test now my actually input and my outputs. Right, guys, that is my story. If there's any questions, guys, you're welcome to ask. This is basically what we also will do within our paid seminars. And if there's any questions, I still need to come back to what you guys have asked about CAN bus. Guys, very important to understand this. To give you a little bit of overview, what CAN bus stand for. CAN bus stand for Controller Area Network. Right? It is a robust vehicle bus standard designed to allow microcontrollers to communicate. Right, there is a lot of different protocol. There's Modbus, there's CAN bus, there's Profibus. The Profibus in CAN bus is also the same as serial communication. Right, it's RS232 communication. That means you utilize a D9 connection, and you can send and receive data from one component to another component. Both must be compatible to communicate via CAN bus. CAN bus is what they refer to, like I said to you, it's actually a communication network like any other serial communication that you experienced before. All right, guys, that's basically what CAN bus is. I can give you a lot more detail about it, but it is actually basically what that is. Is there any other questions?
Nothing at this stage, Davi. No hands are raised or any questions. So if anyone else has a question, please ask now. I will unmute you if I see your hand being raised. Okay, we have a question from Andrew Fraser. I'm unmuting you now.
All right, Andrew.
Yeah, it's just struggling to unmute you on my side. Honestly, I'm not sure if you are there. If you can also try. Andrew, you are self-muted at the moment. You need to unmute yourself to ask the question. Unmute yourself.
Okay, let me quickly see this, Andrew.
Okay, there we go, Andrew. You can talk.
Okay, I've got this Mueller units at my work. Hello.
Which unit you
Yes,
got?
hello.
It's called a Mueller.
Oh, yes.
So if I've got those units,
Yes, sir.
it's basically you don't need to download all the software and blah blah blah.
Andrew, let me explain to you. I assume that is a Mueller PLC that you talk about. You need to go to the website and then download the software. Now, I know that guys also use that's like a smart PLC. It's not like a real PLC in the sense of it's a smart PLC. It's a relay PLC, if I can call it like that. You need to go to the software company, to that company, and download it from their website, the software, so you can program it. Or you can do it also on board. I know a lot of that PLCs have a port that you can connect a serial communication to, and you can actually, with the handheld, you can actually then program it on board onto the PLC itself, or you need to use an interface cable with a PC, with the software, so you can program that. I hope that answers your question, Andrew.
Yes. If you can leave me contact, I'll send a picture of what I've got.
Okay, Andrew, I've got your email address. I see your surname. I say Andrew. I can quickly write it down. Give me a moment. I'll quickly write down it, and I will send the information to you. Give me a moment. I see your email address. Give me a moment. Give me a moment.
Just okay.
Davi, I could write it down for you and send it by chat to you quickly while you wait for another question. While you talk to...
I can send you a mail and I will communicate it to you by email so I can help you with it.
Okay, and then I'll send you a photo of what's available to me. I'm at ATT, Adcorp Technical Training, but I've got these units which not utilized, and that's why I'm attending this course.
Okay. Yeah, no, we can definitely, from Fester's side, we can help you. We can definitely help you with that.
I appreciate it.
Thank you. Right.
Thank you. Bye-bye.
Thank you. Bye. Right. Is there any other questions, guys?
Yes, Davi. Analog outputs. Okay, yeah, I have one from, well, I have a few now. Pneumatics and hydraulics are not on the past webinars. I'm not sure what he means by that. If you, who's this, can you maybe ask us or explain your question to us? Ulysses gone. I think he's gone already. He left. Oh, yeah. Okay, yeah, here he is. Ulysses gone. I'm unmuting you. Please unmute yourself as well. Then you can have a chat to us. Ulysses again. I'm not sure how to pronounce your name. Please unmute yourself. Then you can talk to us. Davi basically asked 3 questions. The first question, I'm not sure if it's a question or not a question, but it says pneumatics and hydraulics are not on the past webinars. I'm not sure what that means, but how can we get a recording of this webinar? I'll also answer that one quickly. Now, we do not record or send out any recordings of the webinars. because there's an IP restriction on that, and some protocols that we need to follow. Okay, analog output is part of your paid webinar. I'm not sure, is that also Graham Barnes? He's asking, is analog output part of your paid webinar?
Let me explain to you. This is actually only introduction to PLCs. We do within the advanced course. Within our advanced course, we do the analog part. We're not doing it on the introduction to PLCs, but yes, we will definitely, if you're attending one of our paid webinars or face-to-face courses, we will definitely do analogs with him. We got an advanced course called CoDeSys Advanced PID. That means for closed loop control that he can attend from us.
Okay, Davi, I think it's also important just to mention that if you haven't programmed before, that they should first come for the introduction to make sure they actually understand the basics. And then if you are a programmer, and then obviously then you can probably do the PID if you are familiar with the normal inputs and outputs.
All right, let's explain to you guys this. Guys, when you're actually attending course from Festo, with Festo, face-to-face courses, we got your introduction. It's a 3-day course. Then we also have a 4-day webinar course that we will run in the near future. That means in this month still. But that is only introduction to PLCs. That's not we only utilize digital in and digital outputs, not analog parts. But within our advanced course, we got then advanced course called CoDeSys, and then after the advanced course we do closed loop control. That is the PID part. Within that PID part of the training, the advanced course with the PID, we do analog part. That's where we do the analogs. All right. Then we go through the wiring of the analogs, the different type of analogs, onto the CECC PLC from Festo. If you're attending a PLC training, Siemens training with us, we also do the analog part also within a PID course.
Davi, we also have another 2 questions. So the one question is, will there be another PLC webinar or training? Yeah, is it going to be a webinar?
Go to the handout, guys. Go to the handout. If you look onto the handout, there is a PDF file that you can download with all the dates of the courses that will be running in the future. The free webinar of Fluid Sim will be tomorrow. Then we can also do it. I will bring it up for you. Give me a moment. I will bring it up for you now.
I think also, David, I think he also wants to know whether there will be more free webinars later on in this year. I believe there will be, and because we also want to introduce other customers and clients to the courses as well. So I do believe that we will have more webinars, free webinars as well. And then the other question from Rose, Davi, was how can programming be done in larger font or screen be made bigger, especially on the recorded bits? I think he's talking about your screen to make it bigger so we can see better.
That's good. That's a very good thing. Right. Unfortunately, my resources running out the moment when because I've got a lot of windows open on my Windows. But let me explain to you. It's a good question. It's a good suggestion what you make. I like that suggestion. But yes, you can enlarge it. But the moment when I go too large, then my resources running out on my PC. Sorry for that, but yeah, I understand that if you cannot see on the screen, it's not so clear. But I will try my best next time to close some of the windows. If you guys, thank you for that suggestion.
Davi, I think also to mention just that we will be doing some of the paid, obviously on Zoom. And there will be other opportunities to enlarge on your own screen that you can see better. So the viewers would be able to
explain. Thank you, Shaw. I think what we need to do is that you guys understand this part now. When we do the physical paid webinar, 4-day webinar, then guys, we utilize Zoom as our platform. And then with the functionality within Zoom is in such a way that we can share your screen to me. You can share your screen to me, and you can give me also access to your mouse, to your control board, keyboard, and we can actually then also help you over the net. Or you can share your screen and I can give you instructions what to do to fix the problem. When it comes to the webinar, online webinar, it's actually in the 4-day webinar. It makes interaction very important, because then you can ask questions, you can stop me, and I can demonstrate to you and show you, and you can show me your screen. There's a lot of interaction taking place when we do the paid webinars. Guys, on the screen currently, for all the guys that's still here, you can see now our 4-day webinars, the price, and also the rand and the euro price. Next week, there's a basic pneumatics course, 15, 17, 90. Please go and register right here on the screen, on that file. Go and register for those courses. Basic hydraulics, 23 to 26 June. Electropneumatics, 29 until 2 June. And then we will have our next PLC course, proper 4-day webinar with a lot of practical and a lot of interaction, 6 to 9 July. And then we also will have actually how to integrate Festo equipment with Siemens PLCs. That is on the TA portal side and also on the Somatic Manager side. What we do actually there in that courses, we actually do the valve terminals, we do the drives, we do the CECC master to slave situation. There's a lot of things that we actually integrated into the Siemens PLC, and I'll show you how to do that if you have an interest in that. Then, like Sean also mentioned. Yes, sir.
Sorry. OB Anderson OB, I'm not sure. He's asking, he's got his hand raised, so I unmuted him. He can ask a question now. OB.
Okay.
Okay. The PLC code system and Siemens PLC system, which of them is more reliable and which do you recommend in the typical industrial application?
Okay, now let me explain to you. I like the way that you ask it, and because I'm working for Festo, I will always say Festo is more reliable. But listen to me, let me explain this to you. They are actually, when it comes to the performance, both have a very stable performance. I must be honest with you, I've worked on both of them, and I've done some projects on both CoDeSys, and I also have done projects on Siemens. I must be honest with you, both of them are very stable. Software, and also when it comes to the hardware actually is robust hardware. It can keep on going, I promise you this. But let me explain to you, it depends on your budget. I must be honest with you now when it comes to the budget. And I'm actually now talking on behalf of Festo. I must be honest with you. The CoDeSys software is an advantage to use CoDeSys software because it's for free. When you go to any other manufacturer, immediately when you buy hardware from them, your software need to be paid for also. That means, and there's a yearly fee that you need to pay every year to renew your license. When it comes to CoDeSys, you don't need to renew your licenses. You don't need to have a paid license. The software is for free. Now you can make a decision now. What do you want to do? Because this is one of the advantages of using CoDeSys. But I must be honest with you, the software, the hardware, both are very reliable and very robust. I promise you will not have problems with it. But you need to train the technicians or engineers or any people that can do maintenance onto it to work with it. And I promise you it will last forever. That's how I can answer you now. If I understand you correctly, which one of them are the more stable one? I would say both of them are stable. It depends on your software and the structure of your software. Your system engineer or your system integrator or your programmer need to know what he's doing. That's why it's good to send him. It's always the best practice to send him for courses. Like we teach him how to do it the correct way, how to maintain it the correct way, how to program it the correct way, how to structure it the correct way. I hope that answers your question.
Okay, Davi, I do not see any other questions. Obi,
Okay,
was
so
that the last question?
Yes, sir.
Okay, good. Thank
All
you.
right,
Is there
yeah.
anyone else? Sorry, say again, Obi.
Okay. Yeah, yes. See, can you clarify more? If I want to know, say the real differences between the CAN bus system and the Profibus system. I'm familiar with the Profibus communication, which we use so much in our place. So I want to know the real differences between the CAN bus system and the Profibus system, sir.
Okay, I actually understand that you actually have what we refer to. You have experience on Profibus. If you know Profibus, and you understand Profibus, you understand that your transmission rate is 1.5 megabits per second. Do you agree with that? Sorry, kilobytes per second. Sorry, 1.5.
Yeah.
Right. When you set up a Profibus system, you must always understand different protocols. Right. It depends on your package. When you send, let I call it like this. When I send a package to you, a data package, that data package are structured in a certain way. That means you got different bits, all right, and bytes, words, double words. It means your size. The first thing, your size of your data that being sent or being transmitted. You must understand it. How fast it be sent, and what frames. How much frames do you use? And also, you must understand now when it comes to the protocol, right? We talk about Profibus. Within Profibus, we talk about token passing. Maybe you know this. When we talk about token passing, that means on a bus when there is a master and there's a slave. On a master has permission to talk onto the bus. That means all the time he can send and receive data. Then you have what we refer to, a slave. A slave don't have the authority to actually request data. He only sends data. Right. Now this is some of the stuff. Right. The same copper cables. For example, if you come to the same copper cables, right? The same copper cables that you use, all right? When it comes to Profibus, all right? Your Profibus got 2 wires, CAN bus got 4 wires. All right, I can show it quickly to you, so you can see it. While I'm here, I've got both the cables right next to me. Let me quickly show you my window. All right, it's a good question. I like the question. Let me quickly show it to you. I'm going to bring up my window. All right. I've got, here in my hand, I've got 2 cables. I can show it to you quickly. Hold on for me. Right, I want to show this to you. Right, on my hand, on my right-hand side, this is the CAN bus, and this is my Profibus. Look at the wires. You can see here, right here. Okay, that's the same end. My goodness.
Davi is just lagging a lot. The lag is just terrible.
Yeah. Let me show it to you like this. Guys, here is a Profibus cable. It got only 2 wires. Where my CAN bus got 4 wires. Okay, that's one of the difference between the CAN bus and Profibus. Right, the number of wires. That means it's also important to understand the transmission rate of the 2. Both are serial communication.
Okay.
Right, both are serial communication. But the thing is now the transmission rate and also the protocol. Right. Now, guys, important to know this, and if you go and do a little bit of research, you will actually find that CAN bus is actually used a lot of within passenger vehicles and buses. All right. Now, this is actually what it also means, that your CAN bus is used more within actually vehicle communication. All right. where in the automation world we use Profibus. But now they actually, a long time ago, they have decided also to incorporate your CAN bus into the automation world. All right.
Okay. Yeah.
I can actually, if you want me, send me your mail address, get me your email address. I can send you information to explain to you more what the protocol consists of, the structure of your frames, that means the data that are being sent, what is inside that data package, what is your transmitting rate, how do you set it up in different ways. I can send it to you. I can actually keep you busy with that until end of days. But yes, it's a good question. I like when you ask the question.
Very good. I'll send my email address to you, sir.
Okay.
I want to have the email address for you.
Right. I will bring it up for you quickly.
How do I send my email address to you?
You can drop it in. You can drop it into the chat.
Davia, I sent his email address via the chat to you.
Yeah.
Okay.
So, Davia, you have 3 emails that you will receive from me.
Thank you. Thank you.
One Andrew, one from and James, and another one you will see, Davia.
Okay, great, guys. I can send you all the information about CAN bus. It's good to know that. Right. Any other questions, guys?
Okay, please raise your hand so that I can unmute you and you can unmute yourself so that you can ask a question.
Okay,
David, there are no more questions, I see.
Okay, thank you, Charles. We can end this.